All right, question one, what is the solution to the equation? All right, so just like any equation, we're essentially going to divide it or write down that equal sign. And our goal is to solve for x, so we need to do inverse operations to isolate the x. So first, let's do the inverse of adding 2 and subtract 2 from both sides. The 2's cancel here. Of course, 9 minus 2 gives us 7 on the left side. So now we have the square root of x plus 3 equals 7. All right, the next step, before we subtract 3 from both sides, we need to get rid of the square root symbol. The inverse operation of a square root symbol is a square. So we're going to square the left side and we're going to square the right side of this equation. So when you square a square root, it cancels out the square root, and we're left just x plus 3, and 7 squared, of course, is 49. Now our last step is pretty straightforward. The inverse operation of a positive 3, we're going to subtract 3 from both sides. These 3's cancel out, and 49 minus 3 is 46. Now that is an option, but with square root, with radical equations, there's possible for something called an extraneous solution. And what that is it's a solution that you get through the algebraic process, but then when you go back and substitute it in for x, it does not make the equation true. So I'm going to rewrite the original problem, which was the square root of x plus 3 plus 2 equals 9. But this time I'm going to replace the x here with our solution of 46 and then verify that this equation is still true. So 46 plus 3 is 49. The square root of 49 we know is 7. And 7 plus 2 does equal 9. So this equation is still true, which means 46 is not an extraneous solution, but it is the solution.